fuller today. I like it.
Monsters are attacking! Ah! Wait, start over because I forgot to hit record. Ah! So there's monsters attacking, and they're really big monsters. They're huge. But how big are they? Okay, so the idea is we talked yesterday about setting a scale, field of view, and if we know, we can like set a scale basically. So we can say, well, from here to here is so big. Then we can say, well, how many of these things can fit in here? And then we should be able to say, well, how big is the monsters? And some of these monsters are very large. I mean, they're monsters. So a lot of times when I think of monsters, I'm thinking of like Elmo, Cookie Monster. But these monsters are way bigger than that because our scale is much, much, much larger than that. So let's take a look at this. So we are going to say the distance from star to star, which is Abbotsford to Wausau, from star to star, is about 30, or no, it is. It's 30 miles. Okay? So from star to star is 30 miles. Once we know that from one star to the next is 30, we can then go through and we can make some estimates. And that's what the backside is going to show us, because we can do the same type of thing with a microscope. Okay, so if we know that from here to here is 30 miles, then what we can do is we can make some estimates. Now, honestly, when I do something like this, I kind of take my, like a pencil, and like, I take a pencil, the pencil's not big enough, take my pencil, and I put it on there, and I roughly, I put like my thumb, okay? So that's about how big my monster is. Because this isn't going to be perfect, it's an estimate, but it will give us a relative size. Now notice, the monster is not quite on the star, so we got to shift him over. And then I can go, well, there's one monster, there's two monsters. Ooh, that's about 2 and, well, that'd be a half. That'd be like 2 1/4. So I'm going to say, I'm going to estimate a number. But I want you to estimate that number quick. You try it. You do your little finger thing. Okay, or with your pencil. How many of these monsters will fit from this star to that star? I have a number in mind that I saw, but I'm not sure it's going to be the same number that you saw. It should be close though, right? We should be close.
If the finger thing doesn't work, just use a piece of scratch paper.
Oh.
Put the end on one, and then I just make a little dash. Right, so I know there's the width of one. So you can just go, there's 1, 2, just about.
Okay, so when I did my little finger thing with my pencil, Cell Theory song. I'm not sure how it's playing right now, because it's not even like, it's not even on.
When's the right time?
With a sign?
Alright, guess I can, YouTube plays in the background. So when I did it, I got about 2.2 was about my number. What was your number?
2.
I got 2.
Exactly 2?
2.1.
2.1?
Measured up.
Okay, so we were all like close, right? But it's okay to get a decimal. Okay, so let's flip this over to the back. Okay, so monster A, that guy. Okay, we want to estimate about how big he is. Now, how far was it from star to star?
30 miles.
30 miles. So we say 30, and then we divide by however many monsters there were. Now, I thought about 2.2. Some of you said 2. Some of you said 2.1. Okay. We can make an estimate, and then you might need a calculator. And in this particular case, if it was a very nice even number, which for this one we can say it is, how big is this monster? He's 15 miles. That's a really big monster. Okay? But, I mean, it's a monster, so, I don't know. So, our scale is miles, set in miles, so we're going to say he's 15 miles. Okay? Let's try one more, we'll just kind of get you going. Okay, so again, 30, different monster, but it's still we're using the same 30 miles from there to there. Go through, estimate how many decimals are okay, and I strongly encourage that you start using decimals. Because it's not always going to be perfect. Okay. About how many monsters do you think that one was? Let's hear it.
3.
3? Was it exactly 3? 3.2 I heard. Okay. Mr. Moore, what did you get? I didn't do it.
Oh, no, I didn't. Hold on.
Okay.
I got it.
2.1 about.
So if we were going to go through and we say, hey, this again, star to star is 30, how many monsters fit across? Pretty close to
3 let's say, I'll go to here. Let's say like 3.1.
3.1, okay. Because it's okay to have a decimal. Because you aren't always going to get exactly the same number of monsters in your screen. So then on the back side, we take our distance from star to star was 30. So 30 divided by 3.1, Mr. DeBoer said his was. So this monster is, we can round to like 1 decimal point, is probably sufficient for our scale. 9.7 miles across. Okay? You try the last two. You try the last two.
Don't forget the units in your answer.
Forget the units. All right, about 20 more seconds. All right, let's talk quick about how big is monster C? Well, I guess let's start. How many monsters would you estimate could fit it between the two stars? Exactly 7?
6.5.
6.5?
That's 6.
6. C.
Well, I got 7.3.
7.3. I think Mr. DeBoer had about 6.7. Okay, so we're estimating, right? We're making estimates. They aren't going to be exactly the same. However, you know, if we're talking like you said there were 7 and someone said 6.1, we're going to be kind of close, right? At least we have some kind of like, whoa, that's a like 4-mile wide monster or a 5-mile monster, okay? Compared to like a 30-mile monster, at least we're kind of in the ballpark, right? That's what we are. We're making estimates. Okay? So your estimates might be slightly different than someone else's, but they should be close. Okay, they should be close. What about letter D? Now he wasn't nice and on the line.
2.65.
2.65.
That's about.
Okay, Mr. DeBoer, looks like you got about 2.6. 2.4. 2.5. Okay. So we're close. So we're right around 11.5 mile wide. Okay. Now we see how to estimate the size. Yeah. You take the distance, and you divide by the number of objects that we can fit across, and then that's our estimate. Okay? So, I want to show you an amazing picture that I drew on the board. So, we can do the same thing with a microscope. And we can go through and we can physically measure what we call the field of view. So what we are going to do with microscopes today is we're going to start and we're going to take a plastic see-through ruler and we're going to put, it doesn't have to be exactly 0, it could be any number, right? It could be any line, but we're going to put one line on the very, very edge. And then we're going to put it across. Now obviously you can't see where this one ends, but we're going to kind of use that as a prediction or an estimate. So I just kind of made this, set the scale. I tried to put these about the same distance apart. So if these are millimeters, how many millimeters is my field of view? About. How far is it from here to here?
About 4.6 or 8.
Okay, so 1, 2, 3, 4. You know, and then again, it's kind of it's an estimate. You know, that's about 5. You know, that'd be like 7 and 0.75, so I don't know, 6, 6.5, something like that. Okay, it's about 4.6 millimeters, based upon my made-up picture here. Now, this amazing picture is another monster, but he's a much smaller monster, and he's under our microscope. So now, we're gonna measure from here to here. Okay, now sometimes you can't do the little paper thing, okay? So sometimes you just kind of eyeball it. So about, and decimals are okay, remember, decimals are okay. I want to get a better angle. About how many monsters do you think you can fit across there?
Let's talk about.
Oh, good. Reference points,
where
yeah.
are you gonna measure
Let's go
from?
from like his body. So we'll go from like here to like armpit to armpit.
Maybe 2.5.
Maybe?
Yeah.
2-ish. Not quite 3-ish though, right? Okay?
2, 3-ish.
Okay, somewhere between 2 and 3, and I'm going to estimate about 2.3. About a third of his body could be another one. So how big is this monster? Well, it's 4.6 divided by 2.3, and 4.6, 4.6, I can't use this calculator, 4.6 divided by 2.3, it's 2. Boy, that worked out way nicer than I was not thinking it was going to work out to be. So this monster is about 2 millimeters. Okay, it's an estimate. It's not perfect, but it's an estimate. Now, what if I were to change power on the microscope? I were to increase my magnification. What happens to my field of view? Okay, so binoculars, like no binoculars, my field of view is right about here to right about here. I can see my fingers. Okay, what happens when I increase my magnification? I use a pair of binoculars. Does it get wider or does it get narrower?
So this number is gonna become what?
Smaller. Yeah, absolutely. So it's going to get smaller. What's going to happen to the image size?
Bigger.
It's going to get bigger. Now, let's just pretend that now my field of view is 3 millimeters. Okay? If this was now 3, he would now be physically taking up more of this space, right? But did his size actually change? No. So when we estimate size under a different power, we should still get the same estimated size. Our field of view is smaller. And once we know those fields of views, we can use that to estimate. We just take what is the field of view at that power, and we divide by about how many of those objects can you put across. It's an estimate. It's exactly what it is. Okay? Today, we're going to do microscopes. There's a couple different things you're going to look at. The first thing you're going to do, there's a worksheet that we'll get you in just a little bit. There is some sketches, there's directions, there's some questions to ask along the way. But you're going to look at a ruler. So you're going to make this direct measurement and observation of what is the field of view of your microscope at low power. Okay? Then you're going to do it again at medium power. And then you're going to do it on high power. Okay? So, from there, we're going to use that we're going to go through and we're going to use that to make some estimates along the way. Then we're going to make some wet mounts. Remember, when you make a wet mount, you start with your glass slide. There are cups of plastic cups with droppers sitting at your table. You're going to put a drop of water and you're going to let it fall on. And you're going to make a wet mount of the letter E. Is like the classic thing that you do is you make a wet mount with the letter E. So on that back wooden table, I have a container of newspaper cut up into little squares. I'll get out a container of scissors. You got to pick up a piece of paper. There's probably more than one E in that little piece. Cut it out and then make a wet mount. You want to make it so your E, when you are making your, it's going to move a little bit, so you want to do the best you can, is like that on your stage. Okay, and it gives you directions on, like, when you look around the microscope, how does it look? Because then you're going to make some observations when you look through the microscope. And it's going to talk about moving it to the left, moving to the right, moving towards it, away, okay, stuff like that. We may not get to the threads today. My guess is we might not get to the threads. When it does get to the threads, it talks about blue thread and red thread. The red thread is on the top and the blue thread is on the bottom. It's on the third page. I didn't have red and blue. I have gold and I think it's more of a maroon. So let's just pretend that maroon is red, and then by default then this of course is the blue. So you'll take a piece of thread, you're going to make another wet mount with those in there. In between, you just kind of give your slides a quick rinse just to kind of help get that off. Although your letter E, you could probably just take a piece of paper towel and just kind of wipe the letter E off. The cover slips are really thin, they're really fragile, they're really easy to break. So they're glass, so if that breaks, it's okay. But be careful so you don't cut your finger. And then just let us know and we can help you kind of take care of that.
Make sure you're starting on low power.
Which is the little one,
Okay,
the
always.
shortest one.
And if you get up to high power, remember yesterday we looked at, we have a coarse adjustment and a fine adjustment. Coarse adjustment, big knob, fine adjustment, little knob. On high, you are only using fine adjustment,
High
okay?
and medium. High and medium.
Yeah,
Yep.
high and, oh, yeah.
Anything beyond low. Okay, now that one has two knobs, like
change
this particular microscope. We got a couple different microscopes in here today. We have, this particular microscope has one But this is your coarse, and then this is your fine, so big versus little, that's kind of the thing. Coarse is big, little is fine, okay? But these are kind of on the same, where these are two different knobs. Hey, we have lots of microscopes. We have 24 microscopes in this room. We kind of spread them out. Notice how
a
they're
record.
covered. What's that?
That's a record.
I think it's the most scopes that's ever been in a classroom in this high school. So, notice how they're covered. There's plugs like right here for each thing. There's plugs, lots of plugs in this room. When you're done, we want to cover them back up, just to try to keep some of the dust off of them. You can leave them plugged in. But let's just cover them up.
Light should be off. though.
Light should be
And it
off, thank
back
you.
on low, so when you're done, always go back to low power. If you use the light, which you probably will, make sure the light's turned off. So, lights turned off, back on low power, covered when you're done.
And we're going to do a lot of walking around and talking to you, because we want to make sure we're on the right track for this stuff. So, if you have questions, let us know. There's going to be a stack of labs here, and I'll put some on the back lab wooden table.